Case study: read the following paragraph and answer the questions. A number of optical devices and instruments have been designed and developed, such as periscope, a device like a long tube containing mirror which allow you to see over the top of something, used especially in a submarine to see above the surface of the sea. Binocular is an instrument with two glass parts, that is lenses, which you look through in order to make object in the distance seem nearer. Microscopes, a device which is used to see small objects, and telescopes, a device which is used to distinct objects, utilizing the reflecting and refractive properties of mirrors, lenses and prism. Most of them are in common use. Our knowledge about the formation of images by the mirror and lenses is the basic requirement for understanding the working of these devices. In this paragraph, a number of devices are given, such as periscope, binoculars, microscopes and telescope, which are utilizing the reflecting and refracting property of the mirrors, lenses and prism. These devices commonly use in our daily life. Our knowledge about the formation of image by the mirror and lenses is the basic requirement for understanding the working of these devices. Question based on this case study are: first one, why the image formed at infinity is often considered more stable for viewing? Explain. Answer: when the image is formed at infinity, we can see it with minimum strain in the ciliary muscles of the eye. There is a little strain in the ciliary muscles of the eye when the image is formed at infinity. So that's why the image formed at infinity is often considered more stable for viewing. Second part, in modern microscopes, multi-component lenses are used for both the objective and eyepiece. Why? In modern microscope, we use multi-component lenses for objective as well as eyepiece. The multi-component lenses are used for both objective and the eyepiece to improve image quality by minimizing various optical aberrations in lenses. We know that there are optical aberrations in lenses. To minimize that optical aberrations in lenses, we use multi-component lenses for both objective and eyepiece to improve the image quality. Third part, write 2 points of difference between a compound microscope and an astronomical telescope. Answer the difference between the compound microscope and astronomical telescope. First point, in case of compound microscope, it is used to observe minute nearby objects. Second one, the focal length of the objective lens is less than the eyepiece lens. Third one, the aperture of the objective lens is smaller than the eyepiece. Now, astronomical telescope, it is used to observe distant objects. Second one, the focal length of the objective lens is larger than the eyepiece lens. Third one, the aperture of the objective is greater than the aperture of eyepiece. Third part, write 2 distinct advantages of reflecting type telescope over a refracting type telescope. A reflecting type telescope, first point, the light gathering power is large, so a bright image of a distinct star is observed. Second point, it is used in astronomy. Third point, it is a hot handy. Now, refracting type telescope. First point, The light gathering power is small, so a faint image of a distant star is observed. Second one, it is used for journal purpose. Third one, it is handy. Case study light emitting diode. Read the following paragraph and answer the questions. LED is a heavily doped PN junction which under forward bias emit spontaneous radiation. Where it is forward bias, due to the recombinations of holes and electrons at the junction, energy is released in the form of photons. In the case of silicon and germanium diode, the energy released in recombination lie in the infrared region. LED that can emit red, yellow, orange, green and blue light are commercially available. The semiconductor used for fabrications of visible LEDs must at least have a band gap of 1 electron volt. The compound semiconductor gallium arsenide phosphide is used for making LED of different colors. In this paragraph we have given a LED which is a heavily doped PN junction diode under forward bias and it emits spontaneous radiation when it is forward bias. Forward biasing means when P side of the diode is connected to the positive terminal of the battery and N side to the negative terminal of the battery, then forward biasing takes place. There is a recombination of holes and electron at the junction. Due to that, energy is released in the form of photons. Silicon and germanium diodes, the energy is released in recombinations lie in the infrared regions. LEDs are commonly we can use commercially are available in the market and that are red, yellow, orange, green and blue in colors. The semiconductor used for fabrications of visible LED must have a energy gap 1.8 electron volt. The compound semiconductor gallium arsenide phosphides is used for making LED of different colors. Here some LEDs are given of different kinds. The question based on this paragraph are: first one, why are LED made of compound semiconductor and not of elemental semiconductor? The answer of first part is LED are made up of compound semiconductor and not by the elemental conductor because the band gap in the elemental conductor has a value that can detect the light of wavelength which lies in the infrared region. Second part, what should be the order of band gap of an LED if it is required to emit light in the visible range? So band gap between the LED is 1.8 electron volt to 3 electron volt. Third part, a students connect the blue color LED as shown in the figure. The LED did not glow when switch S is closed. Explain why. You can see here in this diagram, LED connect with the resistor and with the battery 1.5 volt. In this case, negative side of the battery is connected to the P side and positive side of the battery connected with the negative side of the diode. So it is reverse bias. It is reverse biasing in this case. So no current flow through the diode. When switch S is closed, then there is no current flow through this diode. So the bulb cannot glow. So answer is LED is reverse bias. That is why it is not glowing. Or part, draw VI characteristics of a PN junction diode in forward bias and reverse biasing. VI characteristics for forward biasing: initially when the voltage is increased, the current does not increase. after some times, by increasing the voltage, the current also increase. At a particular voltage, the current increase immediately. That is known as the knee voltage or cutoff voltage. So here, this is the graph, VI graph for forward biasing. In case of reverse biasing, initially when we can increase the voltage, then the current start increasing slowly, but at a particular voltage, that is the breakdown voltage or knee voltage, there is a increase in the large increase in the reverse current. So this is the VI characteristics of reverse biasing.